This method is very closely related to Sanger's original method. However, this one is based more on RNA, which is a close relative of DNA, except thymine is replaced with uracil.
The camera stopped.
I think it has a limit of like.
Why did you? Can you start it again?
Yes, I just did.
Okay.
But we don't know when it stopped.
Yeah, we don't know when it stopped.
But we don't know.
It wasn't a computer plan.
We don't know.
It's okay.
Well, you're only supposed to submit snippets anyway.
Yeah,
you don't
you
want the
only
full
need to
thing.
take highlights, 10 minutes total, so you're fine. Just start it again.
How
And
much time is that, by the way? No, it's 10 minutes.
I'll give you your time.
Okay.
I liked it.
Oh, sorry.
Thank you.
Thank you so much.
Is it okay?
It's still going.
Okay, go ahead.
Okay, sorry.
All right. One of these new revolutionary methods is the whole transcriptome shotgun sequencing method, WTSS, also known as RNA sequencing. This is very similar to Sanger's original method. Instead, it relies on a variation of the DNA. Instead, it's RNA. The only difference is that it replaces one of the bases, thymine, with uracil. DNA appears in almost all of our cells, but RNA is present thanks in parts because we have many proteins, and many bacteria have RNA instead of DNA. This process of shotgun sequencing is highly precise and allowed, in fact, for the entire human genome sequencing that I mentioned earlier. It allows for the analysis of the DNA of even specific individual cells' mutations, and can also analyze the variations of genetic traits among entire populations and groups, although it can't do both at the same time. And it also has a medical benefit. We have the potential for curing genetic diseases, and seeing the variations in groups and populations can allow us to predict genetic diseases such as Alzheimer's or cancers. Not only is sequencing a simply scientific and educational endeavor, but it's also becoming one of a commercial front. This company is known as Illumina, and it's profiting off of developing many resources, genetic-based, for people's and consumers' benefits. Their most popular method is one known as bridge PCR, or sequencing by synthesis, or SIS. This was used in a very interesting way. They have petri dishes filled with water, and stuck to the bottom of these petri dishes are chips. And these chips have synthetic bases. When the DNA is added, strips of DNA adhere to the synthetic chips. And then they continue stacking up onto each other as though like magnets sticking onto each other. What happens is that eventually the researchers add a special indicator ion, one that attaches and is fluorescent when viewed, so that way they can determine the intervals within the DNA. And they add an enzyme that cuts off the DNA strand when it's done, so it doesn't get excessively long. They then flush out the DNA, so that way non-attached strands fall off, and they repeatedly continue the process until they have multiple full-size strands of DNA. And if done properly, all of these strands are identical, which allows for some fairly solid quality control, because if any of the DNA strands have a defect or variation, they can rely on the majority to tell the truth. After looking over everything that has happened, it's it's often interesting to wonder, what should we do with it? Well, there are many benefits to it. For starters, people can be analyzed if they wish for genetic mutations that they might carry. If they have a family history for a medical problem, they can become aware of it ahead of time, and then they can do what they need to prevent it or treat it, either medication or a preventative surgery. So that way they can try and live a longer and healthier life. In addition to it, it can help connect people. You may have heard of some of these companies, such as 23andMe or Ancestry.com, where they use genetics to help connect you to someone you may be related to, or to help locate a long-lost relative. And in general, it's quite useful in crime and with the police. The government can track down criminals better and identify them using any DNA that they find on a crime scene, either blood or fingernail or hair, helping improve safety. But there are also those who are opposed to it, who are threatened by this increased invasion of privacy. They would prefer to not know the genetic disease, that they don't want to suffer with the knowledge. If it can't be treated, why should they have to worry about the genetic disease? Wouldn't they prefer blissful ignorance and live their life? Also, people are concerned with companies potentially profiting off their genetic information to sell it to third parties or to the government. They're also afraid that the governments in less democratic countries may try to abuse this technology. Overall, genetic sequencing will leave a massive impact on all of our lives. DNA is something present in almost all life on the planet, and we need to understand that we will not be able to understand sequencing unless we can use it to better understand ourselves.